in all reality. Like, I want to have another test grade before conferences so that, like, if I have to talk to some people, well, I want to be able to grade it in all reality. You know, I'm gonna be real honest. Like, that's where I'm at with it. I know that's like not maybe the greatest reason from where you're sitting, but like it's kind of where I want to get this in the books so we have another one. But the good news is today I have like some review slides for us, or we can do questions. Whichever one you want to start with is fine by me. If you have questions from homeworks, or if you want to just start with the review stuff. Anybody with a preference? The only person I see doing anything that resembles responding is Braden. Okay, Nolan? So if you do an improper integral and the answer is infinite, that just means it's divergent. If the answer is finite, like 7 or 2 or 0, that's convergent. That's all. That's it. Just a vocab thing, right? Pierce.
I don't really know if this is a question.
You can try.
Could you maybe do like a shell problem?
You know what? I have like review questions, and involved in one of those review questions is a shell problem. How's that sound? I think this is pretty representative of the kinds of questions and level of difficulty that I'd expect you to be able to do.
So if I like mainly study this, I should like if I understand.
Yeah, if you can do the stuff in here, that's like probably pretty similar.
Okay.
Obviously, this is less questions.
Mm-hmm. But it'll be the same types.
Yeah.
Okay.
Yep. I have like an exampler of kind of each type.
Okay.
So this is, and I think again, in general, this is like the same level of difficulty. Okay. So I just have this broken up by section. I figured I'd just kind of slide through, let you guys work on some stuff for a few minutes and then go through.
Is this on?
It will be after we finish here today.
Okay.
How's that sound? Okay. So, yeah, what's up?
Oh no, I was just saying, so like, does the MCQ have a lot of like, there is no MCQ, there's no MCQ. No, not on the test, the MCQ practice.
Mm-hmm.
Does it have like a lot of like shell and washer and disk?
So the shell questions are not in the MCQs.
Okay. Okay.
Period.
Okay.
Has a lot of washer and disk and like miscellaneous volume questions, which is what I call them, where like they say, okay, this region between these two curves is like the base of a solid whose cross sections perpendicular to yada 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 are this geometric shape. Find the volume. Like we did a bunch of those on the board problems when we did the board problems. There's like 3 or 4 of them in there.
Okay. So, but the board problems has the shell method, right? Because I'm just like looking for like a source to study for the shell method, like what kinds of questions.
So look at the stuff in 6.3 that we did as shells.
Okay.
Like it won't be crazy. So again, I just like snagged a question from each topic or section, right? So try this one. It's a 5-5. This is just a general U sub problem. Have a sheet of paper out. Do some writing. You can look in your notes if you want. If you want to use your calculator, I don't know what you're going to do with it for this problem, but you could use it if you wanted to. You wouldn't be able to do it for the test, so I would try to do it by hand. I took your pencil? I'm so sorry. No, yeah, please. I hate stealing pencils. Or pencil stealers, so I don't want to be one. Oh man, that sounded like a subtweet there if I've ever heard one. So everybody's trying to do this as a U sub, right?
Yeah.
Okay, that's good. What you pick as your U? Great. That's great. That's what I would do. In fact, that's what you need to do. You can't do it another way, I don't think.
When do you do like the derivative?
immediately.
U is the derivative?
Yeah, of course.
I always do the derivative of u.
Is that du equals?
It's
the
du over dx equals the derivative.
Okay, yeah.
And then you can multiply the dx to both sides or whatever you need to do to kind of make things match up. Yep.
Okay.
Wait, so the x squared, that's not your u, but when you're substituting in your u, is it like, is your equation, the integral of x squared times the square root of u, or is it u squared times the square root?
It's not u squared times the square root of u. You'll have to do a second substitution for the x squared.
Oh, it's a double substitution?
This is a double substitution problem, yeah.
So you'll just use some other value.
No, you use the u you already have.
So do you do 2 plus x squared? Or no? I don't know.
So I'm gonna take my u. I'll subtract 2 from both sides, so I know x is u minus 2. I took my u, I subtract 2 from both sides, so x is u minus 2. X squared then is u minus 2 squared. Then I can substitute in, and my integral now has only u's. I can't do the integral if I have x's and u's. I have to have just one variable in there. I'm waiting.
Wait, I'm not.
Wait, did you get the du equals the x equals the derivative is just 1?
Yes.
Oh.
And then I have du over dx equals 1. I multiply both sides by dx.
So then you just get like du.
Yeah.
How does x squared equals u minus 2?
Well, if x is u minus 2, if I square both sides, right? Well, because we chose u to equal 2 plus x, right? If I subtract 2 from both sides, x is u minus 2. And then x squared is u minus 2 squared. And then I substitute all that stuff in, so I can replace the x squared, the x plus 2, and the dx with all things with u's in them. And now I'm ready to integrate. What did I do on that third line?
Wait, but how do you get the u?
Just simplify the middle. Did you FOIL out the
I FOILed this out, and then what?
multiplication?
Multiplied through the u to the 1/2 to get that. Where did I get what? So I FOILed this out, and then I distributed through u to the 1/2.
Oh, okay.
So u squared times u to the 1/2 is u to the 2 plus 1/2, which is 5 over 2.
Oh, yeah. For some reason I got multiplication, not addition.
Correct.
Did you do the study?
Yeah.
Oh, so you're just studying it in here?
She wanted to come for another one.
Oh,
Do some more practice.
that's good. I missed study hall.
Oh. Oh, I had the hard part down and I made this.
Clearly.
I had the hard part and I counted that.
That's doing a kulik. Is when you do the hard part and then you goof something simple.
So how did you get this last part, the 2 7s, 2 plus? I'm totally blanking. You integrated it, right?
I did the antiderivatives and then plugged the 2 plus x back in.
Wait, so you subtract 1? Is that the rule? So 5 over
I added 1
Oh, add on 1. Yeah.
and then divided by, in that case, 7 over 2. If you're talking about the first one.
Yeah. Thank you.
Wait, so
Yes.
that becomes 5 over 2, right?
It'd be 4u, or 4 times u to the 5 over 2 divided by 5 over 2.
Oh, wait, I'm sorry. Yeah, okay.
And then when I like take the fraction out of the denominator, it becomes 4 times 2/5 u to the 5 halves.
Okay.
And that's 8/5 u to the 5 halves. You're welcome. If you feel like coming back, you're welcome to come back.
Oh, yeah, I definitely will.
Okay, sure, any day.
Okay. Wait, when do you not add the plus c?
Uh,
So this is an indefinite integral, so you add it.
Correct. If you see bounds,
No?
you should have no c. If you don't have any bounds, you better have a plus c. We feel ready for the next one? Give it a try.
Yeah.
All right. Should be able to use a calculator on this one. In fact, you'll want a calculator on this one. So you're looking for the area between two curves. I don't know how you're going to know what the picture is going to look like without the calculator.
It's just we did this such a long time ago. Like,
Those of you that are in physics, what should you do before you start typing stuff in your calculator? Yeah, get back into radian mode. Get out of physics land. God bless you. So you guys got that, right? That's your region between the two curves. What important observation should you make at this point? Yes! Exactly. Yes, Braden, you nailed it. So we noticed that they switched which one's on top and which one's on bottom. So you're going to have to find where they intersect and do this as two separate integrals, right? So we'll do the integral from 0 to intersection, top minus bottom, plus the integral from intersection to pi over 2, top minus bottom. But it's a different top and different bottom, right? They switched. What's up? So you have this area and then this area. There's just two. Area between the two curves. So this one and then this one. X equals 0 is the y-axis. Not y equals 0. That's okay.
Where are we saying it intersects at?
I don't know. Where does it intersect at?
I use my calculator.
Great. What'd you get?
0.52.
Okay. You could probably get away with a decimal. What I would try to take all of the decimals to get my best answer possible. Although that should be a number in terms of pi, right? What could you do to find that number in terms of pi? I would just like do pi divided by and just do a guess and check, because it's probably a unit circle angle measure. What are the typical unit circle angles?
5/6.
Pi over 6, pi over 3, pi over 4, pi over 2. It's probably one of those. Pierce is right. He said pi over 6. You can just guess and check it. It'd be fine with the decimal, though. If you're going to do the area or do the integral on your calculator, the decimal would be fine. Yes. And then pi over 6 to pi over 2 as your second integral. If you're trying to do this algebraically by hand, you would have needed to remember the double angle identity for sine, which is 2 sine x cos x. So if you set those cos x equal to 2 sine x cos x, subtract the cos x over, factor the cos x out, zero product property, set each factor equal to 0, you get, you get 0, I'm sorry, you get pi, and then pi over 6. I'm sorry, pi over 2 and pi over 6 are your two solutions you'd get.
Wait, so if you're doing it on your calculator, that first portion, you're 5
If that's the way you wrote it, yes.
and then the second one is y2.
Correct. Yep, 100%. I wrote it on the answers like that, where I put the function names in there for you. What's up?
It's like when I did the intersection part, I just felt like weird.
Right. That's fine. Use that instead of pi over 6, but use all the decimals,
Okay.
and it'll be fine. You'll get close enough to 1/2 that you'll probably round it to 1/2 anyways.
Wait, so are you not allowed to put in L1 minus L2? You have to have.
You mean y1 minus y2? You can do that.
Yeah.
L1 minus L2 is going to not be really confused at what you're trying to do there, putting a list inside of an integral.
Where's the tire?
So if we look at the graph, the point where they intersect was pi over 3, or I'm sorry, pi over 6. And the end of the function is pi over 2.
In the second interval, you have pi over 3.
Oh my goodness. Yeah, the pi over 3 is wrong. Shoot. Yeah, thank you. I'll update that when I post this.
What is supposed to be instead of pi over 3?
6. If you're integrating with respect to y, it would be right minus left. If you're integrating with respect to x, top minus bottom. Great!
Whoa. This is like, can I charge my calculator and use it?
Sure. Yeah. Power up. That's what the chargers are here for, is your use. They're plugged into the power strip.
I just want to make sure they weren't all.
If they were, you could unplug it and just plug yours in. It's okay. I'm sure that one that's been sitting there has been sitting there for a while. They don't take that long to charge. All right, you guys ready to do another one?
Not really, but okay.
Yeah, just add them.
Sketch the region and find the volume.
Wait, this is good.
Yeah.
How do you know if you're doing right minus left or left minus right?
Well, it's always going to be right minus left.
Okay.
But that's only when you're integrating with respect to y.
This is a long time, Mr. Ford. Can I figure all that like a washer thing?
Well, do you know it's a washer problem yet?
Well, I don't know yet, but it could be, possibly.
It could be, yeah.
Maybe it is.
Could be a disc. We don't know yet.
I don't know, we'll find out.
Oh, well, you're gonna have a whole. Because it's why it goes more than the
Your hand really?
No, doesn't it look like a hole? Oh, wait.
It should.
So my graph is
Y equals, what is Y? Or it's like a,
So your shaded region is this part right here.
what is the negative x look like? What is either negative x look like?
This curve that I've drawn in here.
Yeah.
Again, these would be calculator questions on your test, right? So you would be graphing it on your calculator. Is there a gap between the axis of rotation and your shaded region? So so your shaded region touches your axis of rotation?
Oh, wait, that's Y equals 1. It's a washer.
Yeah.
It's a washer method, yeah.
Yeah.
How do you know it's not a shower? It's normal.
Well, because if you try to do the washer, it's really easy.
Alright.
Wait, it's a washer method because there's a hole, right? Between y equal 2 and the curve?
Yeah.
Okay, perfect.
Yeah, I don't do discs if there's a hole. You do washer if there's a hole.
If there's a hole.
Or an indent.
Washer is just like this minus this, right?
Yes, that's exactly what it is. 100%.
What's an indent? Like, what would an indent look like?
Wait, are we doing the top or bottom?
So this is your axis of rotation, the thick line.
Yeah.
The region between the two curves is that.
Yeah.
So what is it?
So that's an indent?
So if, to answer your question, Chanel, if we had rotated about the y-axis,
Yeah.
nope, I want to,
Sorry.
if we rotated about the line x equals 2,
There'd be like a large.
there'd be like a whole, like an indent in the middle, right? It would be like like if you, like when you hurt your butt and you have to sit on one of those donut things, except it connects at the bottom, right? It's got like an indent in it.
What do you call it? Like purple? I don't know what the brand is, but like that's spongy.
Yeah.
It's like, yeah.
But that's a concavity, right? It has like an indent in it.
Alright, thank you.
How do I know that this is what?
Okay. So this is the axis of rotation right here, right?
Okay.
This is the shaded region, right? This area between the two curves.
Mm-hmm.
You see how there's an empty space between the axis of rotation and the shaded area?
Oh,
That'll always mean you're doing a washer.
Because there's a space.
Yes, because that means there's a hole through the middle of your solid. Ben. Yeah, sure. Yep, flipped on its side. Yep. Yep.
It'd be like kind of like a bubble.
No, it'd be 2 plus.
It'd be 2 plus?
I think so.
Well, we're rotating it.
I can't see it.
Well, why would it be 2? Because it isn't like full.
No, 1 plus.
Yeah, do 1 plus, right? Yeah.
About 1 plus. So, see the line on the top?
Oh, no, you're right. Here's.
Yeah.
That's the end.
It's 2 minus.
So you see shape at the bottom, how it's like a fin? That
Yeah.
fin.
Because our outer radius is this distance right here.
Yeah.
So we know here to here is 2. We know here to here is y. So the distance we're looking for is 2 minus y.
So see
That
this
makes
thing?
sense.
This is your triangle.
Yep.
Imagine it's like this. If you rotate this all the way around,
Why couldn't it be
it would
1
be like a
plus?
volcano shape, right?
1 plus is going to be like sitting in here somewhere,
Imagine my pencil with the
right?
axis rotating.
It'll be, because you're just going to go to 1 and then go whatever that distance is.
If I want to make a cut
right? Which is not what you want,
Okay.
right?
Yeah.
And rotate it
So
around.
cool, like, I have a
And if
question.
you had my
Yeah.
fingers in all of these
So
directions
I'm
at
just
once,
kind of
it would
confused
blow
how you
up.
got the, I understand
If
you
you
got
had this triangle wrapped
the
around the whole
outer,
thing at
correct?
once,
Yeah.
there would be a gap.
So I understand how you got the outer, but the inner, how'd
Does
you
that
got
make sense?
one for
Okay.
it?
That's
Well,
the best
it's
way.
the distance from
And then
y equals 2 to
You're
y
not
equals
looking to,
1.
like, see something there. You have to
Because
visualize
it's at the very
that
tippy
shape
top.
wrapped around.
Because that's the beginning of the shaded region, right?
Yeah, and that's the inner,
Yeah.
Mhm.
yes. And but the
Really-
outer
really-
one,
really easy
two
way to
minus
explain
y,
Mhm.
because it's the actual curve that you're subtracting.
'Cause it's the end of the shaded region.
How many you want rotated, that's how I imagine.
So you've gone through the entire shaded region and stopping.
So this is, sorry, so this is, from here to here is inner,
Yes.
right? From here to here is outer.
So see where so like here to here, that's the outer.
How come it wouldn't be all the way over here? Because like when you're, I'm trying to imagine it. So when you're.
This is the shaded region.
Oh, that's the shaded.
Yes. It's between the curves y equals 1 and y equals e to the negative x.
So is this wrong?
You didn't graph y equals 1 and y equals 2. Right? So there's y equals 1. That's our axis of rotation. So the area between the two curves is there.
Oh, now that makes a lot more sense. So yeah, so this is obviously the beginning of the curve. That's the just the one, and then the end of the curve. So that's the outer is the end.
Yes.
Got it. Okay.
Yes, yes. You can ask questions.
No, I know. She just doesn't know how to phrase it.
You can
I'll figure it out.
do the best you can with it. I can help walk you through. I'll ask questions if I'm not sure.
How do you, this is such a dumb question, but like,
Nope.
how do you know whether to use the area of the left under
So you're saying
under the curve or
why
over?
here or why there?
Yes, yeah.
Here's how I know. If I go back to the original problem, this stuff is describing the area. So it's between this curve, this curve, this curve, and this curve. X equals 0 is this. X equals 2 is that. Y equals e to the negative x is this. Y equals 1 is this. The region between all of that stuff is here. Right? Where this shaded region borders y equals 1. It borders e to the negative x. It borders x equals 2. And it borders x equals 0. Right? If I went down to this area, this doesn't border y equals 1. It borders y equals 0. Right? So this area down here is not in between these things. Right? These are describing the boundaries of our shaded region. So if your shaded region doesn't border all of the parts, you don't have the right shaded region. Did I do it?
Yeah, I think so.
Okay. I tried real hard.
Yeah.
Okay. Chanel.
So like okay, so how can you be sure what the bounds are? Does it literally just?
I'm telling you right here.
Oh, no bounds like when you're making the integral.
Oh.
Like from 0 to 2.
Okay.
Is it literally just when the curve starts and the curve ends?
So here, kind of. So when we're slicing this, we're going to be slicing vertically, right?
Yes.
So my first slice is going to be at x equals 0. And I'm going to keep slicing until I get to what x? X equals 2. So that's my bounds of integration because I'm integrating with respect to x.
So you would be slicing vertically if you're on y-axis, like
if we're rotating about a y-axis and you're doing a disc or washer, yes.
But x-axis it's horizontal.
Yes. You mean if you're integrating with respect to y, you'd be rotating about a vertical.
Wait.
Here we rotate about a horizontal,
Yeah.
and we're integrating with respect to x.
Okay.
If you rotate about a vertical,
Vertical.
and you're doing disc or washer, we integrate with respect to y.
Okay.
Okay.
Can you pull up the calculator again?
Oh, sure.
So why is it -1 when like it's like think about it as like this is the area of the curve under 1 and we minus the area under the curve of this. So then it leaves you with that. So why is it -1?
So this is a washer shaped. So what we have is
Is it top line from this?
if I cut this, we're going to have a shape that looks like our cross section is going to look like this, right? So this is like y equals 2. This if I'm looking like down it, right? So this is y equals 1, and this is y equals e to the negative x, right? So I'm going to do the area of pi e to the negative x squared, and I have to subtract out this empty space, which is pi 1 squared.
So I have to think about it from here, not from this line.
Yeah, you have to think about it as like a slice. So you have to like think about it in 3 dimensions, cut it, and then turn it, and that's why the formula looks like that. But it's always going to be inner minus, or outer minus inner. And the way I can tell the difference is if I go from my axis of rotation to my shaded region, the first curve you intersect is going to be the inner radius, and the second part you intersect is the outer radius. It'll always be that way, whether you're going like left and right or up and down or whatever.
If you had this at like x is -1, you'd start with the e and then the y.
Yes. So if it was y equals -1, then this would be the inner radius, and to there would be the outer. Exactly. Yes. Very good.
Hey,
Emma, what's up?
where does 1 and 2 minus e to the negative x come from?
Okay.
I'm so confused.
So this is our shaded region right in here, right? So our inner radius is going to be the distance from our
Yeah.
axis of rotation to the first part of the shaded region. That's here. So we go from y equals 2 to y equals 1. Our inner radius is 1. This is the line y equals 2. This is the line y equals 1. So straight down is 1 unit, correct?
Yeah.
Okay.
I know that was y too. It looked like it was y. Like the 0. It looked like the
So it's came from the problem, right? So now for the R outer, it's going to be from the axis of rotation to there, the end of our shaded region.
Oh, so that's wait. No, that's
So I know this distance here is y, and I know this distance is 2. So the distance from there to there has to be 2 minus y. Yeah, we're
that's 1. That's y.
well. It's the point is x comma y, right? The point right there would be x comma y, right? So if I wanted this distance, that'd be 2 minus the y coordinate at that point. And the y coordinate at that point is that,
Oh.
because y is equal to that.
Oh. And then -1/2.
Where do you see -1/2?
Or 1 squared.
So it's r outer squared minus r inner squared. That's the formula for a washer.
Okay. I did not think that was
What's up?
Oh, I didn't get the other
I'm gonna post it, so it's okay. You'll get it all. Okay. Next one. Sketch the region, find that volume.
Would you only put y equals 0
Like a hump.
Kind of like a football.
Yeah.
Maybe like a fat football.
How did you do that without graphing?
Is this, this is the y-axis?
That's wild.
So this is your shaded region, right? Between y equals 0 and the curve.
It's like kind of it's like the tip of a football.
But that's what it looks like right now, yeah.
Well, if you spin it, you're just spinning that piece. So it's going to have a point at each end, and it's going to get fat in the middle. It's going to be like a football.
So is this a washer method?
I wouldn't wash it because it's not concave.
Right.
This is convex. There's no hole or indent.
Yeah.
This should be a washer.
What? Why
Oh, wait,
Or I'm sorry, disc.
Is it this because it doesn't have like a hole in it?
So yes, if I'm rotating about y equals 0, you see how the shaded region touches y equals 0 the entire way? That should be telling me it's a disk.
And then shell, is that just because it has a thick like
We'll see what a shell one looks like in a second.
That's when you're going your outer Y curve.
Perfect. Perfect answer.
I need to but
We'll see one.
what?
That's better.
Okay. Yeah. Makes sense.
So that should be your disk.
Wait, what's
Right? So the radius is just the distance from y equals 0 to the curve. Well, that's just the y coordinate,
the volume for it would be what?
r squared.
Oh, it's just higher.
Just pi r squared.
Oh yeah.
There's no holes between the shade area.
Wait. Oh, so it's the last one.
And then the washer method was pi times.
R outer minus r inner. Or r outer squared minus r inner squared.
So with that one, let's say this were no calculator, and if I had to simplify that, would I be plugging I'm trying to figure out how to explain this.
That should be to the fourth,
Can you not tell
What was
us
that?
just?
Okay.
right? Because x squared times x squared is x to the fourth.
Oh yeah, alright. So yeah, and then for this, would I be, if I were, I'm trying to figure out a way to.
So if I were doing this by hand,
Yeah.
there's a shortcut here that I would have used.
Are you going to?
So notice this is an even function.
Yeah.
So I would have done
This weekend? You have leaves this weekend?
I'll make one right now.
Yeah.
and that makes life quite a bit easier.
What we're doing is we're basically.
I'm making one right now.
This is only 6 points.
Third.
So like this one's the best, right? Which is a straight up set. So we're using the
So
equation.
2 pi, and I have 1 minus 2/3 plus 1/5 minus 0. And then it's pretty easy to go from
Easy from
there.
there, yeah.
Does that feel okay?
That does, yeah. And just,
And you could do what you're doing from there. I mean, you have to fix this piece because it's to the fourth.
yeah.
But you'd have, plug ones in, so you have that thing.
Yeah.
And then minus, and then negatives of all of those. So you have to
Yeah.
make sure you distribute through your negative or whatever.
And-
And then put the pi through.
Alright.
Like I would just do everything in, get that down to a single number, and then slap the pi in at the end.
Alright, that makes more sense.
Right? Like I don't put the pi through. It's just gonna make a nightmare for you.
Yeah, thank you.
I literally didn't.
Don't
Do we
die.
have these on the test?
Then I have like a test on Friday, so it's like a big test. I'm stressed.
So, just as a reminder for the test formats, so the calculator section is going to have the area between two curve problems, the volumes problems. That's all your your calculator questions are all areas and volumes. You have access to your calculator. The directions will tell you to use your calculator to do the integral. I don't want you to do the integrals by hand because you won't have enough time. Okay? So these volume problems, you're just plugging into your calculator after you set it up.
Algebraically.
Correct.
Oh.
Oh, we just do it in
Yes.
At least you don't have to do this.
All right, let's try this one.
it's a, yeah. I'm gonna guess it's a shell since we're working on.
You are, that's excellent. That's excellent. There's something to be said for just like understanding how your teacher's going to ask,
Right.
like design something. It's like, okay, we've done a washer, we've done a disc. Let's take a bet that it's gonna be a shell.
Wait, what'd you say? Did you say my name?
No, shell. He said shell.
Shell, not shell.
But shell.
What? What? Who said my name?
You said shell, I thought you said shell.
Yeah.
What? That's a shell. Oh,
They call me Shell.
Kinda.
So this is the.
That should be a senior quote. They call me shell.
So
That's a 1 point.
this is our shaded region, right?
Radius or something.
And we're rotating about x equals 0,
Mine is literally
X
my
equals
the y-axis.
Mine is shell number 1.
So if you tried to use a washer here, you'd have R inner minus R outer. But I noticed that R inner and R outer are the same curve. How do I tell, like write an equation where it says that R outer needs to be this part of the curve as opposed to that part of the curve? When it is y equals sine of x squared, yuckarooskies, I have no flipping clue what to do there.
I agree. I don't know.
So what should I do instead of trying to washer it? Shell it.
Chanel.
Yes, the Chanel method. Now, if you get it wrong on the test, I'm going to be mad. So what's the formula for shell method?
2 pi r f.
2 pi r h.
Yeah.
Yep.
I knew that one.
So should this be, again, my radius is going to be perpendicular to my axis of rotation. It's perpendicular. X equals 0 is the y-axis. So we're going to be drawing our radius perpendicular. So the radius is going to be x. The height then is going to be up to the curve through the shaded region. It's going to be y, or sine x squared. Yup.
Wait, so the radius is x? Why
Yes.
is the radius x?
It's a bar.
So my axis of too much yelling going on at one time. The axis of rotation is x equals 0, right? So when I'm building out my cylinder, like the smallest cylinder I'd build is here. That's a little tiny cylinder that's real short, right? And it gets a little bit wider. The next cylinder I draw is like there. The next cylinder I draw is kind of out there. Every time I extend my cylinder, it's going to be further down. It's just going to be the x value, right? Your radius is always perpendicular to your axis of rotation, whether you're doing a disc, washer, or shell. Your radius is always perpendicular to the axis of rotation. But look at how easy this was to do as a shell.
Yeah.
X was the radius and Y was the height. Like, there's really nothing to manipulate. There's no subtracting of anything. You'd have to, like, solve for a different variable or, like, rearrange. There's nothing. It is what it was. So the R inner would be like this point, this x value, right? And the R outer would be this x value. But those are, for a washer, well, there's a hole in the middle of this, right? If I rotate around the x-axis, I need to be slicing this way. I'm sorry, x equals 0, right? I'd have to slice this way,
Okay.
right? And I notice that for each y, there's 2 x's on that function. Oh no!
I thought you were rotating on that.
Oh, yeah, if we're rotating about the x-axis, yes. Disk it up, homie.
You were saying.
Yeah, Christian.
For the other ones, does it have to be perpendicular or does it matter? Does it not? Like
Does,
for a disc and washer, you have to be perpendicular.
yes, to the axis of rotation. That's how you're doing your slices,
For all of them.
for all of them.
So X is 0,
Or your radius is I should say your radius is always perpendicular to the axis rotation. Because you're not doing any slicing with a shell. Right.
is just X, but X.
Because, well, the base of my cylinders are all gonna start on the x-axis, right?
Yeah.
So they're gonna, the start of my radius is at the axis of rotation. So just like there could be a radius, there could be a radius, there could be, so there's x values, right? And then the height of the cylinder is gonna be just how high the shaded region is, right? So the height to the curve, which is the y coordinate, right? So this point here is x comma y, radius comma height. Let's try this one. This is one of these miscellaneous volume problems that you guys saw in the multiple choices.
Oh, I wasn't here for this. Oh, wait, we do this.
I haven't started. I meant. I think that's what you're talking about.
Yeah, the board problems.
Oh, the board.
So this will be on the test.
Yes.
I don't have my calculator.
Grab one.
Wait, what? This,
Yeah, I'm listening. Yeah.
it's a straight line.
So in the first quadrant,
He just fit the window.
Yep.
to it.
Yeah, I was like,
so the cross sections are perpendicular to the y-axis. So like this right here, right? And it tells us that the cross section shape is a square. So it's the area for a square.
wait, Jesus, length times.
How about side squared?
What's
So X squared.
So the length of the side times the length of the side. So side squared, right?
So it's just, yeah, right.
Because base and height are the same, or length and width are the same in a square, right? So this is my side length for my square, right? Because it says it's perpendicular to the y-axis. Well, that's just a generic one, right? At each y value, you have like a different square, right?
Oh, so you just chose like.
I just pick a representative one to imagine in my head. You know, like I'm just picking one to just imagine what this is going to be. So this should be my side length. What's that going to be?
X.
That's an x value, so I have to rearrange this to be x, right? So there's my x. And then I'm integrating with respect to y, so I'm going 0 to 4. Side squared, dy, dunzos. Yeah.
What are you essentially doing? Circle it.
So I subtracted 4 to the other side and then multiplied by the reciprocal, which is negative 3/4. 3/4 times 4 is 3. Yeah. Chanel, what's up?
So what are you essentially doing in these processes? Are you doing like a washer method?
No, neither.
Like, is there square? What?
What's it smell?
Squares. Because it tells me in the problem that the cross sections are squares.
Oh, wait, you just make a square. Like that's all you're doing.
It tells me that this is how we're doing the cutting. It says perpendicular to y-axis, and it tells me that when I do that cut, I get a square.
Okay.
So like the distance from x equals 0 to the curve is one side of my square. Well, that's all I need to do the area of a square. So that's it. Because the area of a square is just side length squared. So, oops, let me get my calculator.
I saw like the
So we're cutting, our slices are happening here, right? So I start my first slice here at y equals 0, and it goes all the way up to y equals 4, right? And I just keep slicing. Christian.
Why did we use X?
Because
For the earlier, the sine X squared.
so that was a shell method.
so it's and it was across the it was you were X Y axis.
It was the same axis.
Right. It was rotate, but there was a gap.
I know it was like
There's
different
like a
between
dip,
shell
right?
and I know it was not. It wasn't square. Like we were.
So what does this three-dimensional shape look like?
I don't know how to imagine a square one. I got like.
Okay. So it's like, if it sets on the ground, it's a triangle, right? Because that's this, and then up. So like this piece of the triangle is the tallest piece. And as it goes further down, it gets to like a point. So it's kind of like a wedge shape. Is that okay? So just kind of like down to 0. So it's like a wedge. Does that feel okay?
Yeah.
I guess so.
It's like a triangle of that. I just didn't know. How did you know it was a square specifically? Is that just what this is? Oh, sorry.
For each solid, or for the solid, each cross section perpendicular y-axis is a square.
What I wasn't here. Is it just squares or is it like triangles?
It could be triangles, it could be rectangles, it could be, but it'll give you some. If it's a rectangle, they have to give you some other information, like whose width is like 5 times its height. Well, just like whatever the width is x or y or whatever, and then the height would be 5 times the width.
So I have to know the area for each then?
Areas of basic geometric figures like triangles, rectangles, and squares, and circles, yes, you should know those. Pi r squared? Yeah, you should know that. You know circles. Pierce, what's up?
Oh yeah, go to see what's 7
No Friday.
Actually, I'm gonna be on.
On a problem like this, it'll tell you.
Well, what about like the when you do the shower or washer like this method, like sometimes like you'll do a Y,
It stresses
you'll
me
put
out.
everything
Whenever I
into
miss
a
one,
Y
it's
sometimes. Like I
Let me
don't
monitor
understand like in what scenario
I
would
see,
you do
because
that?
I'm the one keeping track of that, so I don't even.
So if I did it, will you just
So,
say, give me
For
that?
you, you probably have. Only because.
What do you guys think?
It is actually.
right? So, if we're slicing,
Wait, where does your brother go? He has to do like a certain amount of hours.
right?
Yeah, that's what instead of like.
So this is an x value, that's an x value, right?
What is that?
And like.
Pierce has asked me a hypothetical question that's unrelated to this current question we were talking about. So this means that I need to take write this as x equals,
Yeah, that's what they don't miss.
and I need to write this as x equals, because if this is like point A comma B or whatever, I'm going to be slicing starting at y equals 0, and I'm going to end my slicing at y equals b, right? So this one would need to be in terms of y's, because I'm slicing horizontally.
Wow, you done?
When you're slicing horizontally,
Yes,
Yeah.
and when slicing
I
vertically.
have
Yes.
Holy bags take home 200 candy grams.
All right.
Them by myself.
Uh, these are back to no calculator problems.
Must be nice. I did that too.
Oh, that looks so terrifying.
So basically, I was not in third grade at the Wolverine.
Back to no calculator problems.
Bro! Sorry, I did not mean to call you bro.
That's okay. You can call me bro.
I don't like this. I don't like this. Did we get a snow day?
What do we see here? What are we gonna do?
Fraction?
It's a fraction. Great.
So you have to do the U as the denominator.
long division.
You should be dividing here, but you could do long division. But look at the denominator.
Okay, so then set it.
You could do a synthetic division here. I would.
Because instead of doing long averages,
Wait, why did you do negative? Because then you multiply that.
why is it minus one?
You add down multiply.
Set the denominator equal to 0 and solve.
Oh,
Let's go.
I didn't know you could do that.
First time doing
Sorry, or I didn't know you could do that.
So,
When you're getting negative figures, you're multiplying by negative 3.
Yes.
Drop the 3 down and you multiply by negative 3 and then.
Yeah, doy. I don't know how I got 100 numbers in that division. I don't remember
How do
where
you know
I
that
did
you're
it.
not? 3 is your constant?
Because the
So
last
you
one
always
was
read from right to left. So it's remainder, constant, x, x squared, x to the third, and you just keep counting out however many numbers. You just go up one more degree.
Did we do this last year?
Yes,
The synthetic division?
yes,
Oh, okay, that's how I know it.
yes. In the regular trig and pre-calc, we do it. Not in honors.
No, regular. That's how we
Yes.
What's after the 3 and the negative 5 there?
R and C. So like what these numbers mean if we read from right to left,
Oh,
starts remainder, then it'll be the constant, x coefficient, x squared, x cubed, x
is
whatever.
that the answer? Or no, did you?
No, that's just how I have to set it up to integrate.
Right, I
Oh,
did
then you
that.
have to integrate?
You need to find
Yep.
the derivative? No, it's a joke.
So now you can use sub this piece, but this piece you can do directly, right?
What do you mean?
Well, what's the integral of 3?
Because you have to live on
What? The integral?
Yeah, the integral of 3. It's 3x.
How? What?
Well, what's the derivative of 3x?
Oh, antiderivative. Oh.
Yeah, antiderivative,
Oh,
yes.
that would have made sense if someone said that. I don't know.
That's okay.
I need
Like,
more basic.
Yeah, no, it's okay. Ask if you did the right thing. Tell me you're confused. Being a little bit more specific would have been helpful. Like, I don't know what you mean by integral.
I'm like, what?
Would be-
the antiderivative. Like,
Yep.
oh, okay.
There's that. And then to do this, we have to do a
I remember doing that.
U sub, right?
U sub? You use that?
Yep.
I just saw it because, like, since the bottom, it has X, so it's just what I do. Like, she was saying it was, with the X plus 1, and you wouldn't have to do it again, and the X is, like, it's just, I don't remember how she explained it.
But yes, this is like almost like a nothing burger U sub.
Yeah, because it would be like the constant comes out.
Yes.
And then you would do the value.
Uh-huh. Yep.
If it's only X or something, it's like if it's only X alone.
Yes.
Can I go blow my nose real quick?
So I learned so weird way. That's
Yeah.
I'm all mixed up. Just doing the different.
What about this one?
No, you can't. You get to do long. No.
You can't divide this.
Because the X is bigger than X.
The denominator is bigger than the numerator.
Wait, what?
U sub won't work on this.
Wait. Is it just number?
2 and x minus 1.
Okay, to do what after we factor it?
We do the A and B thingies.
The partial fraction decomposition.
Yeah, it's so easy.
Quiet.
So that should be your partial fraction decomposition.
Whoa, we went up 2 steps.
I did a lot of steps there.
Let me.
Oh, okay, sorry.
What's that? No, I already. Can I see it now? I need to
No, do it. I'll take my time.
I can't. X plus 2 and x minus 1, which I thought would work.
You know how to factor x squared plus x minus 2.
That's what you did on the denominators.
Yeah.
Yeah, that's what I'm saying.
Okay. You said you needed to copy it down. I'm like, you know how to factor that.
Oh.
That's like an algebra 2 problem. At best, it's really an algebra 1 problem. Should be.
Don't you multiply it by
One? Actually, yeah, it would be.
or like you separate them and then you multiply it by both of them?
Yep, you clear the fractions. Yep.
Okay, so I have the x plus 2 and x minus 1 is denominators, but then on the numerator.
So you set up the equation x over x plus 2 times x minus 1 equals a over x plus 2 plus b over x minus 1.
Yeah, wait, hold on. So it's x over. Yeah, I know that. And then you multiply everything from that. So
By
it'd
the
be x equals.
So you multiply both sides of that equation by x plus 2 times x minus 1.
Yeah, so it's x equals.
So you have a times
Oh yeah, a
x minus 1
x minus 1 plus b times x plus 2
equals x.
Yeah, or I did x equals.
X.
Doesn't matter how you do it. I did
Sure,
x
yeah, it doesn't matter. Then you distribute the a and b through.
I just didn't exchange with Jill.
Oh yeah, this is where I did it differently. So it'd be ax minus
He said, no, I
b8,
said, really?
Yep.
He said, maybe.
and then plus bx plus 2b
Yep,
equals x.
yep. And you use that to write a system.
This is where I get confused because ax, so it's ax plus bx equals x.
Great. Or I would just write as a plus b equals 1.
How? I don't know how you do that. I don't.
Well, what's the coefficient on the x?
X. Wait, what?
What's the coefficient on x? 1. So if I add ax and I add bx, I have to get 1x. Or just a plus b has to be 1, right?
Would it be just x then?
No. A plus b equals 1.
Oh, then where does the x go? Does that just disappear?
We don't care about it. Because we're not trying to solve for x. We're trying to solve for a and b.
So it's x equals 1?
No.
What? I'm so confused.
A plus b equals 1.
So it'd be a.
So if I do ax plus bx, that has to be 1x, right?
Yeah.
Or just a plus b equals 1,
Okay.
right?
Yeah.
And if I take negative a plus 2b, that has to give me the
Negative
constant.
What? That's nuts. No, wait.
Why did you separate? Why did you separate ax and bx to that?
Well, I know that if I combine like terms,
Oh.
if I add ax and bx, that has to give me the coefficient on x, right? If I add the constants to like terms, negative a and 2b has to give me a plus 0 at the end. And I'm just going to solve that system.
Because 2 minus 1, that's 1.
So then I'll do like elimination or something here
Elimination?
to solve the system of 2 equations. Or substitution if you prefer.
So you sub in 1 for these? Wait,
Well, I would do elimination.
I don't know how you do.
So I'm going to take each of those as 2 equations. I'm just going to add them together because in doing so, the a's cancel out, right? So a plus a is,
0. Or wait.
b plus 2b is,
3.
1 plus 0 is.
1.
So there's an equation with just a b in it, right? So b is 1/3.
Okay.
And if I plug that back in over here, say to this one, what does a have to be if b is 1/3?
A equals 1/3. Because it's 1. The 1.
2/3 plus 1/3 is 1. Right?
Sure. I don't know. I'm so confused. I don't know how to do this anymore.
So
I get that. It's just this part.
So don't write any of that there. So now we can say that this integral,
Like, I get it from there, because then you plug in the A and the B.
literally stopped by. We're literally neighbors. We literally worked together for like freshman year. I'm still partially centered on zombie.
And now you can go.
Let's do the antiderivative.
Yes, of each of them.
I don't know what it would be for. Would it be like 2? Oh, it's just the same. Never mind. They're 1/3 of.
Right?
I just. Those two just confused me a lot because I didn't know we had to do elimination thing.
You'll always have to solve a system when you do a partial fraction decomposition. So you can do it as substitution or you can do it as elimination, right? Either is okay. If you feel better about substitution, you can do it that way.
Because it's with letters, so I was so confused because I was reading it this way and not following how I did it.
Oh, so we don't distribute it?
So I actually really think that's
Great.
Yeah.
The only thing I would change is X plus 2, right?
or is this?
All right, you ready for the next one?
Oh, wait, 1 sec.
No.
Oh, I did.
Oh, wait.
Okay, so when I had the tutor, what she did was she took a number that would eliminate like the A, B, or C with it.
Right. We didn't have to do that because it was already, one was plus A and the other was minus A. So we didn't have to like multiply anything through to do the elimination. It was just like ready,
That's why I
tailor-made.
was confused because you did elimination. She just like found a number for like either one of the two that would cancel one out.
Mhm. And we was already set to do that. Like you could think about multiplying both by 1. Because if you do that, then the A's will drop.
36 years off the school.
I got,
So I could do that, but the elimination thing was quicker.
You're doing elimination with what you're saying.
Oh, it just wasn't in the way you did it. It wasn't in like the 2s. She just did like x equals 1 and then plugged it in and it would be like plus 0. Hold on, I'll show you.
What's up?
I got 30.
But I don't want to say high school.
I think that this is right.
Like here, this is
Hold on one second.
sorry. Because this is what we did x equals 1 and that's how we got B and then we did a different number then we got A. That's why it got a little, that's why I was confused from compare what you did. She just did a different way. She still got the right answer, but that's what's working, so I don't know.
Guys, it's really scary how fast it's gonna go.
Because I had her when I was gone.
Yeah, I don't know why she's doing it this is not at all the way that I would do that.
Okay.
I always write a system.
Okay.
And this is much harder than anything you'd have to do. Just FYI.
Yeah, we were just.
Yeah.
It was just. This was just one. I think.
Yeah, from the textbook.
Yeah.
Probably, yeah.
So we just decided to.
Yeah.
Just practice it.
This one is like massively harder than something I'd ask you to do.
I didn't find this one too horrible. for some
Yeah.
reason.
Well, just like you have like
It's all like
this is a
X.
3 variable would be a 3 variable system.
Yeah.
So it'd be like a kind of
You'd have to do the first 2, and then you'd have to sub in the 1 with the C.
No, you have to do a 3 variable system. You can have like 3
You have to
equations.
times 2 like different whatever in order to get like the one row to like exit out.
Yeah. All right.
Yeah, I just wanted to show you that because I was a bit confused.
Sure.
I have all the right numbers. It's just that in your answer, this was here and this was here. I don't know where I'm going wrong. That my A and my B got switched up. That started down.
So your B you got was 1/3.
Yeah.
Okay.
I knew her.
So that looks good.
Thank you, Mr. Clay.
Oh, wait, should we go?
I don't know what you're looking at.
So mad AP Bio is like the last exam.
Existing.
It is not.
Do not care about AP.
Nope.
This is long division, no, because the top is bigger than the bottom, right?
Hey, Holden. That looks right. Thank you. Are you okay?
Because the top's bigger than the bottom, right? The top bigger than the bottom, right?
What?
Where
I don't know.
Yeah.
Can you go to the next thing? I want to see what the answer is.
No, try it.
I don't know how to start it. I really don't. I don't.
You want to do completing the square.
What is that? What? I don't know. I don't know how to do it. I don't know how to complete this
We
goal.
have, it's like b over 2 squared.
Yeah, I can't do that.
Sure.
I literally can't do it. I don't know how to do it.
4 over 2 squared.
That's like my cousin. She can-
4.
What do we do with the other?
Is that it?
X plus 4
Wow. Maybe?
How?
squared.
That's actually.
You have to multiply both. You multiply the top and bottom by a half.
So b over 2.
Oh, because we want the 1/2 there, right?
Well, you need a 1
Then
well, yeah.
plus 1.
Because that's gonna be what?
B over 2 squared.
Minus.
Is that what it is?
Is this?
Yeah, b over 2 squared.
But it's 1.
No, it's
4 over 2 is 2
4
squared.
over 4 is 1.
Where are you getting the 4 from?
Where?
b over.
4 over 2 is 2. 2 over 2 squared is 2.
Actually,
I don't know. Chris, I can't.
That's fine.
I don't see it right now. Maybe I typoed something wrong here. Let me check real quick.
4 over 2. What's 4 over 2? What? 2? Yeah, 2 times 2 is 4.
Yeah, so it's 4 on the lower. So that's 4.
What? I feel like you're always doing that. Where's 4 over 2? Is he right?
What?
Oh, wait. Can you go to the next one? Slide real quick, please. I want to see if I'm right. I don't know where 1's coming in.
You literally just proved it. No, it was 4 over 4.
Where's 4 over 4?
No, that was why are you doing it over 4? No,
It's 2 squared.
it was numerator.
Oh, that's what
B over 2 squared, right?
Yeah,
I got it. I over 2 squared. This is 4. 4 over 2 squared is 4. Actually, and like I didn't even like.
Oh my god! Literal? So what is it? Wait, so, okay, wait. What, wait, where did the b over 2 come? Where's the b over 2?
It didn't show it. Oh, right here.
So where does that come into play now? This is actually.
It's breaking up the bottom part of the problem. That's what it's for.
Oh, wait.
That's what I'm saying.
So would you do the, wait, would you do 6 or 6 minus 2 for the C, or like 6 or whatever? I don't remember. No, it'd be 6 minus 4, 6 minus 4, right? How did you get the x plus 2? Is x plus 2 from the 6, like the 6?
So,
It's 2, is it 2 root 2 over 2?
Yeah, really, hopefully,
Oh my god, twin.
yeah, so just.
Notre Dame comes out in like 1
You got this.
Okay, wait, 2, oh, it's b over 2.
I manifested you.
Yeah, but 2a, wouldn't that be, oh, because it's 1. Oh, okay.
I don't blame you for saying reacting like
It's okay, people say that whenever I say that to you.
no, but
Where is
if I
my
hear
hat?
rejection Notre Dame, I really don't care.
I feel like I'm gonna fail.
No.
That's usually like MSU.
So then b over equals 4.
20 people.
Oh, so you just put it at the end with the 4. That's just what your C is, or not C, but like.
Yeah, no, this is
Oh wait, technically, wouldn't it be C then?
what? I'm sorry, what?
Would it? So the 4 that goes to where the 6 is, and then you subtract that 4 from the 6, and that's how you get the outside.
Yeah, it's 4 plus 2.
Can I take first grade on?
Well, it wasn't that.
You didn't get rejected, you got
I just knew that I wanted to go.
This was the worst one.
Is that gonna be on the test?
Might not be this hard, but
Can it be the same trig identity?
maybe. Of all the examples we've done, have we done a different inverse trig function?
Huh?
Of all the examples we've done, have we done a different inverse trig function?
Thanks, Mr. Colex. I already need this. Cannot. Whatever.
Yeah, Pierce, I think I just goofballed those coefficients.
Okay.
In the cut.
If the whole thing was negative, wouldn't it just be
Probably one more after this one.
Okay. And just review and maybe a few more different things.
I have like one more chapter's worth of stuff to do, and then we're gonna probably just start reviewing.
I'm just waiting on money.
Yeah.
Well, do you want
You guys got worked real hard
do you want?
so that we have enough time to like
Yeah.
decompress and like do some high level stuff like where you see problems where all of the concepts get thrown in jumbled together, and you have a chance to see that and practice with that and like review some of these ideas. Bye. You're welcome. Have a good day.
I regret to inform you were shut out again today.
Ah, man. I'll be down to check on some other things in a second. I'll be down to check on some other stuff in a second. Okay, Cusack. I need to make sure.
Well, beating us.
Okay. Low. McGregor. Let's go put these in. Stupid thing.